Again, good afternoon. I wanted to quickly introduce myself and my colleague here. I'm Narendra Narang. I'm one of the principal storage SAs with Red Hat. And then I'll let Dan introduce himself.
Hi, I'm Daniel Smith. I'm head of operations and infrastructure at Kaloom.
So again, welcome. What we're going to be talking about today is, we talk with a lot of customers, and we're in the field a lot. And the one thing that's well, to start off with, I'm aligned primarily with the telecom vertical here at Red Hat. So over the past couple of years, Red Hat's been verticalizing some of its focus. And one of the key focus areas for myself has been the telecommunications industry. And in speaking with some of our largest customers in this field, what we've noticed is that they've come to us with some they have a lot of data, and it comes in and it spews in from a lot of sources. And they want a way to basically analyze this data. But how do they do it in a way that's more standardized on a stack that they can actually evolve over time? And when they build essentially this data pipeline, what does that pipeline look like from end to end? So basically, I'm going to walk you through a journey, or take you through a journey of what I've been through in, like I said, working with some of these customers to build this data pipeline for microservices. All right, so telcos are experiencing, so where does this stem from, right? There's been a huge culture shift organizationally from the top down, sideways, however you want to look at it. And this is aligned with three key, I like to call them tenants, which are basically where telcos want to either save money, they want to make money, or they want to go faster. And what I mean by that is they essentially want to evolve the way they do business and the way things are done today. Because they either want to keep their customers happy, or they want to gain new customers, or they want to generate new areas of business to generate new revenue streams. And in fact, even how they can exploit their existing architectures and monetize them with the data that they're already collecting. So based on that, this mindset, and this change in culture, there also needs to be a change in process. And for most of you that have or for some of you that may not have read, the Open Organization by our CEO, Jim Whitehurst, this talks a lot about these tenets and how Red Hat aligns very well, with some of these facets of thinking. So this is essentially the new reality, and what's based on this culture shift, right? The new reality is that there are more services. There is a need for more services. I mean, just think about the folks in this room that are holding a mobile device, of whatever size, of whatever resolution, and you not only use it to receive, right, to view content, but then you also use it to communicate with the outside world, right? So it's a two-way street, and this essentially results in this whole ecosystem of services that are, every day, you hear about a new company that's offering some sort of new streaming service, or it's offering some sort of communication service, and it's all traversing, right? I mean, we take it for granted, but it's all traversing this telco infrastructure, right? The telco infrastructure they've invested in over many years, but it essentially is a finite set of resources. So how do we make better, more efficient use of this infrastructure? Now, in talking with our customers, because and I keep bringing this up because this is not something that we've built or we're trying to or this is not our opinion or something that we're just trying to force upon the larger community at large. This is something that we've worked on collaboratively with our customers. They really want a way to develop these services, to release these services, and adapt very, very quickly to align with the open source nature of the technologies that they employ. It has to be very agile in the sense that the pace at which they deploy these services and the pace at which they evolve them is increasingly rapid. And then it's also about the decentralized nature of where these services are offered from. So think about where core services were offered and now where edge services are offered, and there's been a sort of a disintegration with, or I should say a disaggregation of these services, because there is no need to have that centralized or to deploy a centralized architecture anymore. And it's all about the users being able to drive the need for these services, right? So it's us, the people in this room, the people at this summit that are all, and then in the cities, right, across this country that are driving or are the driving force behind the need to develop these services. But how do telcos do it? With this, with the immense participants, right, that are us, there is an immense amount of data that's generated, right? And with each new subscriber who has one, maybe more than one device that's communicating, there's an immense amount of data that's generated. But how that data is transported and how that data is if they need to provide you with some feedback, that needs to be done reliably. And longer term, there's going to be even more companies who are going to be able to offer even more of these services because the ability for them to extract or to monetize these services is going to be drastically reduced, right? Because they can't just keep increasing prices. So they have to find a better way to do this. Now, what they all aspire to, you'll see the acronym here, which is, of course, the logos speak for themselves, but essentially everyone wants to be like the Facebooks, the Amazons, the Netflixes, and the Googles of the world, right? But when you think about what these companies really deliver, I mean, it's a set of services, but it's really lacking, the telco infrastructure, right? It's just services that are being deployed on this infrastructure. So what I want to draw your attention to for a moment is, I'm going to just talk very briefly about this path because I did mention it's going to be a journey. But if you look at the left-hand side of that screen, it essentially is, the focal point is the level of automation, right, that is required, and that's actually being appreciated by these telcos, right? So as you move from, having or managing all types of workloads in a single cloud management platform or a network function virtualization infrastructure, right, the NFV stack, or it's just doing something, consolidating your infrastructure on OpenStack, or whether it's modernizing your applications and really undergoing their transformation, to then undergoing a full-blown optimization of the services, the buses that tie all the services together, all the messaging pieces, and as well as the making your services more elastic, right? Because elasticity, just scaling up is one aspect of, or one dimension of what you can accomplish. But what about making your services more elastic so that they can you can align with that economic model of what you're providing to your customers as a service? Again, very quickly, we've all undertaken, I'm not going to talk to you a lot about, containers because we've all, they've been around for a while. We all understand what, the value that microservices and essentially containers can bring. But what I do want to point out is, and again, this is from working with a lot of our customers as they undertake this journey, that, as we move from the traditional to the virtualized to a containerized model, what you'll see at the bottom is, is rather than just pretty fractals that you'll see there, are essentially what we've, a term called, a snowflake, which is essentially something that you've built, and then it's almost like what we refer to as a Frankenstein, right, or the exception in your architecture, which is, you've had it there for so long, and now you've just built upon it, and now there's no way for you to move away from it, right? Or it becomes one of your essentially your pets that you have to feed and take care of, in terms of the infrastructure. Well, the problem with this type of architecture or this type of pet mentality is that when you want to undertake an architecture that aligns with something on the right, it's very hard for you to invest time and resources in something in the left, right, that looks like that, because those are not very easily reproducible, right? And maybe the skill set that developed that in the past doesn't exist anymore, right, within the organization. And the services, in fact, that leveraged that infrastructure have become irrelevant. Maybe you don't need them anymore. So, I just want to, again, just point out to you something that Martin Fowler, I came across, he's a pretty prominent, in the industry. a server should essentially be like a phoenix, right? Regularly rising from the ashes, right? So we've all seen the Harry Potter movie. We all know what that means, right? It's essentially where you need to be able to spin down and spin up very, very quickly, right? And without impacting the architecture or the environment at large. The other thing I want to very quickly draw your attention to is, this is something from Amazon Web Services, right? Because I did mention that, everyone wants to aspire to be the next Amazon, right? Great, but how do you do that? So if you look at the model on the left, this is essentially what is depicted here is an economic model, right? Which is, you'll see the solid line in red on the left, which basically tells you this is how when you self-host and this is your infrastructure, this is how it's going to scale based on the supply and demand. The problem is, if you look at the dotted line, it doesn't align very well because of the rigid model of how those infrastructure, when you look at capacity planning, for example, how do you capacity plan for a service when you don't even know what the number of subscribers for that service is going to be in the future? How do you know if that service is going to be a success, if it's going to be a failure, right? How are you going to be able to generate revenue from that? How do you go out and invest and justify that internally within the organization? How do you do that, right? Well, when you undertake an effort like that, essentially what that results in is, initially, is waste because there's excess supply. But then, if you look at the top, there's a lot of customer dissatisfaction because there's not enough supply, right? Or there's excess demand for that resource, but it isn't available. For whatever reason, you don't have enough infrastructure built out. You didn't do you didn't perform or whatever estimates you plugged into your capacity planning metrics didn't pan out. And then you look at the right, and this is essentially what you see in terms of how you can tighten, right, or become very well aligned with the demand and supply curve. More importantly, this is what our customers talk to us about all the time, right? So there's many vendors. If you go to our partner pavilion here, if you visit the pavilion, you'll see that there's tons of vendors, and they're all participating, right, in these discussions with the same customers. Now, what they're really looking for is they want a way for us to interoperate. Very, very important. But they also want fungibility. And what this essentially means is, it's an industry term for basically saying they want something that's modular, right? If I have, for example, one piece or one container platform, or if I have one technology that is then leapfrogged by another, I want to be able to leverage the better technology, right, without impacting my environment, right? So the pieces have to be very modular and replaceable. And then they want some standards built around it. So yes, you want the freedom and you want the open source and you want the ability to be able to pick and choose your components. But the architecture still has to be standardized, right? You need some rules around what that architecture needs to look like. And then just very, very quickly, right? So, we talked about, in the previous slide, we talked about operational efficiency. But along with that also goes along, things like automation and orchestration and monitoring. So with very low operator to asset ratios. So we don't have, for every switch or for every hardware server or storage array or whatever it might be, we don't have a singular person, right? The ratios are very, very low. So you need automation. You need the ability to be able to, configure, deploy, whatever it might be, all these assets. And then you need a way to monitor them. So you need to tie them back to your business metrics that are defined. So, not just automation for the sake of automation, but really need to be able to tie them in to what you're automating. Because if it's a really iterative process, it's very justifiable to automate. And then you really want to get from this whole, you want to get from this mode of CI/CD to this mode of continuous operation, right? And this is what microservices afford you. And then, if you look down on this chart, it was a chart, something that I borrowed. The link is down there, but it was very interesting. The rights are reserved by the gentleman over here, but it was very, very interesting, very, very pertinent, because if you look at automation and you look at orchestration, respectively, on the automation on the y and orchestration on the x-axis, you'll see that there's a tremendous differentiation between the capex and the opex model, right? Now, telcos are very, very capex oriented, and they really need to start. When we talk about this culture shift, this is where, as you can see, the high value items, right, which are predictive analytics, the machine learning, the artificial intelligence, these are all OpEx related, right? They need to change their mindset to be able to move into that mode. And then monitoring these key metrics is absolutely essential, right? So things like service assurance, optimization, right? So I have things deployed, how do I make it better? How do I fine tune it? And then analytics, whether it's for infrastructure related analytics or even for your subscribers, right? How do I monitor what my churn rate is for my subscribers? How do I monitor which subscribers are loyal, what services I need to market to them, etc. And with that, I'm going to hand off to Dan.
Thank you very much. Can you guys hear me okay? Yeah, it's all right. So before I get into the slide deck, I just want to kind of touch on the stuff that Narendra started. A little bit myself. I started in telco industry about 20 years ago. I was quite young. And it's exactly as Narendra described. In the old days in the telco, every year you did your capacity planning exercise, and that was we expect X number of growth, X number of churn, and that will translate into X number of servers, and we're good, and hopefully we did it right, and if not, well, we have to buy some new ones. But that was also in the days when there was lots of CapEx, not so many players. There was maybe 5 or 6, 7 big vendors. Guys like WhatsApp and Facebook was still 5 years away. And that sort of waste to customer dissatisfaction scale that we saw in the first couple slides was very prevalent. And that was okay. Because at any given moment, I see that I'm starting to get close to 99%. I'll just add some more hardware on the end. But that only takes us so far. We start to run into issues about scalability. We start to see OpEx costs go way out of control because we have to have more people or we get more dependent upon vendors, which, depending on your business model, can or cannot be good. So all that to say that we have seen the shift in my lifetime has been so dramatic that now we see a complete opposite approach to the way that we want to do dimensioning, to the way that we want to even see marketing companies set up for campaigns. It used to be we do a marketing company and they're going to roll out X number of servers and we expect 100,000 people to hit this app, and so we'll dimension accordingly. We buy a big server and it didn't hit, and we only got 100 people hitting the app. But we got all this huge hardware that sits there. Trust me, the next time that I ask for a budget to buy hardware, it's not going to happen. What does this mean? Well, let's take a look at a new architecture. Let's get away from sort of a black box vertical architecture, and let's talk about an integrated open horizontal architecture. And I mean, I'm not going to go through all of the sort of buzzword banner stuff, but the goals today are agility, elasticity. It's almost in line with the sort of the just-in-time or just enough capacity, and the ability to be able to dynamically manage the capacity within your data center. If you've got, if your data center is nice and flat and you've got an application over here that's hot and you've got an application over here that's cold, should both of those applications be given the same amount of resources? Well, of course not. And that's what we're talking about when we get into the combined Red Hat Kaloom solution. And what is the combined Red Hat Kaloom solution, you might ask? And here we go. So from the base, the Kaloom Flow Fabric is an integrated and certified component in the Red Hat ecosystem. And what that means is the Flow Fabric, we're providing the layer 2 to layer 7 fabric that composes one of the 3 tenants of compute, network, and storage. So as we said before, we've got our old rack. I got a server rack, and I've got a storage rack, and I got top of rack switches, and I got an end of row switch, and I got all this stuff out there. And each one of those is it's a pet almost. I have to manage all that. I have to have expertise. I have to have, I got a Broadcom here. I got a Cisco there. I got all this equipment all over the place. I got an Extreme. I got other stuff, and I've got to have competency for each of those. So one of the first tenets that we're talking about in the Kaloom Flow Fabric architecture or ecosystem is relatomic everywhere. Now, when I say relatomic everywhere, you might say, oh, but then that's easy. It's in the switch, in the it's in the compute, it's in the storage. We're talking about relatomic in the fabric as well. Okay, so the Kaloom Flow Fabric, we have the single OS across everywhere. So now we've addressed one of the key components in this shift or in this transition that we're at. Now all I need to do is I need to have all of my guys know rel. Whether you're working on server backend, whether you're a storage guy, whether you're a networking guy, you're all going to be working off the same OS. So right off the bat, the homogeny within my operations brings a benefit. Okay, I don't need to have concentrated centers of knowledge vested into individual people. Okay? As the competency grows within my organization, and remember, when I say organization, I'm talking about a continuous integration, operation, and development environment. You're pushing code every 20 minutes. You're releasing all the time. You know, one of the big tenets of CI/CD, and one of the things that we're shooting for is from idea to release in under an hour. And this is realistic. Now, it's not all predicated. There's a lot of guys working very, very hard on it. But it starts with these basic tenets. So I've talked about the Kaloom flow fabric and the fact that we're talking about a single OS across the place. Now, Kaloom has partnered with Lenovo, with Red Hat. And Lenovo, you can come over to our partner booth. Lenovo has been kind enough to give us some really, really nice servers. It wasn't the OCP stuff, but they have to show their stuff first. Lenovo provides us with the baseline hardware, and this is a certified package. Okay, when we start to talk about pods, you know, we don't want to have a pod that's got what's the word I'm looking for? Dishomogeneous? Heterogeneous, sorry. Our pods, we're talking about, come pre-certified, okay? So you've got your RHEL running across everywhere. We have our full CLOS architecture. And again, I'm not going to go deep into it right now because I want you to come and see us in the partner booth. But why? Why? Well, I mean, we can read off the slide a little bit, but many of the service providers today, a lot of the enterprises today, they want to deploy at scale. For me, scale starts at 2,500 servers. A pod under that size, I mean, it's exciting, but it doesn't really get my heart going. You know, we've been building pods that big for a couple of years now. So we want to talk about scale. And there's really 3 tenets to do in scale nowadays. We're talking about the containers that's running off, you know, RHEL Atomic. Okay, everybody knows containers. You know, Narendra, you touched on it. I'm not gonna to go into too deep about that. But again, we're talking about, you know, we want to have these sort of FANG data centers. Okay, when we talk about swapping out servers, when we talk about operations, we don't swap out 1, 2 servers anymore. We swap out the whole pod because it's more cost effective. Right? The paradigm has shifted from the capital investment where I have a black box to an operational investment where I have to make sure that more effort has gone into my ops guys. And why is that? Well, it's because we used to have this tower of engineering, and we used to have this tower of operations. You had the engineering guys who would do all their work, they would deploy to engineering, and the operations guys would go nuts and say, oh my gosh, it's not ready, and then it would somehow there would work out in the knock, and a couple engineers would have 2 weeks off, and somehow it would work out. But now, those 2 groups that were traditionally sort of, I don't want to say diametrically opposed, they are now the same group. They share the same responsibility. No longer is it, hey, I do my CapEx, I set up the service, and I hand off the ops, and my job is done. No. What we see now is the same engineers that are developing the solutions, they own the solution from the time it's from inception to decommission. Okay? That's the real DevOps model. The kicker to this is most of us don't have the resources to do it the way that we want. Okay? It is big. It's a big thing to take on. If you want to become Google, you know, they didn't just do it overnight. You know, there's a lot of engineering that went on in there. There's a lot of commitment, and really most of the service providers and the enterprises, they don't really have the resources to build this technology independently. They want to use the industry standard. They want to use the proven technologies, but adoption is tough. I want to do what Google does, but I'm not Google. This is where, you know, again, Kaloom, Red Hat, and Lenovo, we come into the picture because we're going to provide the 3 tenets of scalability. We're talking about full IPv6 support, you know, right out of the box. That's our bread and butter. Full containers across everything that keep our OpEx low. The same stats and the same monitoring that you use for your Ceph storage container, as we're going to get to, is the same one that I use to monitor my traffic on my front-end servers, is the same one that I use to monitor my load balancer that sits somewhere in my fabric. Okay? Imagine all of a sudden you didn't need to have an F5 guy, an Extreme guy, I don't know, a Solaris guy, for all of you sort of old-timers. You just need guys that know RHEL, Atomic, and Docker, and container base. So what have we done? Well, Red Hat and Kaloom, we've joined forces, again, with Lenovo, with a formal technical and a go-to-market solution or collaboration that's going to provide these industry-leading tenants, as we talked about. The Kaloom product, little plug here, is the Kaloom Flow Fabric, and it's combined with multiple Red Hat open source software development to provide this sort of full-end solution. Now, why is this important? I'm a big OpenStack. Any of you guys that have ever been to an OpenNV event in the last 5 years, you've probably seen me kicking around. I'm a huge fan of OpenStack. But this is a problem. The first problem that I have with this is my computes are doing networking. Why would I buy a server to do networking? Remember, when you install OpenStack, if you're doing it right out of the box today, chances are your control node is your network node. Or you've got a dedicated network node somewhere else, but it's a server. So you're buying a compute to do networking. This creates a whole hassle. There's a lot of tromboning that's going on, and I'm not using my compute for what it was meant for. My dad always said you always get the right tool for the right job. You know, and the idea of using a compute to do your networking, it causes problems. We've all seen it. We know OVS has overhead, and then we can get into the discussion about DPTK, and then you get some guys over there, we don't need it. We can do all sorts of different stuff. But this is all predicated on one common problem. We're not using the right tool. Okay? So what I'm going to do real quick is I'm going to flip to a video that's going to describe a little bit about the tool that I'm talking about, because I'm sure you're sick of hearing me already. And then when we're done, I'm going to come back and we're really going to go into what the Kaloom Fabric does and how this is going to benefit you guys.
Applications, but you don't have the resources, and you also want to use industry-leading and proven technology and techniques, but you know you can't do it independently. Red Hat, Kaloom, and Lenovo are here to help. Red Hat, Kaloom, and Lenovo have joined forces to deliver a combined solution, integrating the Kaloom Flow Fabric into the Red Hat ecosystem. Kaloom software runs on commodity open networking hardware, incorporating commercial silicon available from many well-known white box vendors. It requires no changes to the operational model or physical configuration of the data center. To make things even easier, thanks to tight collaboration with Lenovo, the Kaloom combined solution can be fully integrated, certified, and delivered on Lenovo hardware, which means the entire package can be provided through a single, reliable source. What about security, reliability, availability, and serviceability? Kaloom uses the same mainstream OS distribution as compute and storage, so you can manage everything the same way and eliminate the vulnerability of non-mainstream hacked Linux distributions. Kaloom is purpose-built for the networking requirements of container-based environments and supports the increase in networking endpoints and density while supporting microservice-driven changes in traffic flow. In a data center without Kaloom, applications and networking containers are all running in compute, causing high latency and low forwarding performance. Plus, each networking function has to be managed independently. With Kaloom, each container type runs in an optimal environment, thereby eliminating congestion, increasing compute density, and dramatically improving efficiency and performance. In addition, Kaloom's networking integration into OpenShift enables you to rapidly build, deploy, and manage applications and networking in a common framework. You also gain full control of tenant-based container separation, allowing controlled and secure communication between tenants. And you get distributed internal monitoring and collection of telemetry to measure and support SLAs. When you're ready to deploy massively scalable data centers with a single OS distribution, optimized container networking, and the ability to manage compute, storage, and networking in a common framework on the same Red Hat Enterprise Linux distribution, look no further than the Red Hat ecosystem and the Kaloom Flow Fabric delivered on Lenovo hardware. Learn more. Contact us today.
I'm going to speed this up a little bit because I kind of dragging a little bit for time. So I really want to reinforce for you guys the data center with Kaloom. And this is really what we're talking about. We want to do the work up in the fabric. We want to let the compute be the compute. We want to let the fabric be the fabric. We want to reduce this tromboning. We want to make sure that we've got the security, we've got the, the security, the tenancy, and the separation that we're looking for. But we want that speed, too. So really, we want everything. And this is one of the building blocks that's really going to get you here. So I'm going to summarize the key benefits again. We're talking about single OS distribution, security, serviceability consistent with operations, optimized container networking, so the highest networking performance. We don't take the hit doing compute. Networking integration into OpenShift. So true compute, storage, and network managed common frameworks. We talked about enforcing the tenancy. And the one that we really want to focus on is the internal monitoring and the measuring to support SLAs. SLAs are important to telcos. Telcos have lots of SLAs. They've got SLAs between each other. They've got SLAs to customers. The whole point of why do we do telemetry, telemetry tells me where I stand, not only where I stand capacity, where I stand contractually, what do I need to do in the future, what didn't work, what does work. And I mean, that's really what monitoring is about. And so with the Kaloom fabric and with OpenShift, we're talking about distributed monitoring and collection. So if I was to tell you that I have storage on my fabric that writes statistics every second, but that storage is actually an RDB mount that sits out in some other distributed storage Ceph container, you might say, well, that's pretty interesting. I might say, yeah, but this also means I don't have to sacrifice support. I'm not doing polling. I don't take a CPU hit on my fabric when I want to do more in-depth analysis. And if I lose the switch, all my telemetry was already off on another server somewhere. So those are some of the benefits we're talking about. Deep packet inspection, stateful pipeline. And I think I'm going to pass back to you, and you can kind of wrap us up and take it from there.
You want to finish the...
Yeah, sorry. And so these SLAs, I mean, the SLAs that we're talking about, low latency. Low latency is key. If we talk about 5G and some of the IoT stuff that's coming, the ARPU is very, very low. But the demand requirements, it's not going to be high bandwidth, but it's going to be very low latency. They want to get that information quick. When we talk about automated cars, when you have 10,000 cars on the road, they've got to be able to talk to each other so quick, it's going to be unlike anything we had seen in the last 20 years. But the telcos have to support that, and it has to be supported on the same radios and in the same common network that supports your voice call, your VoLTE call, your narrowband and your wideband beamforming. All of this stuff has to happen all at once, and guess what? At some point, it all enters the same data center. And how are you going to manage that? And this is what we're talking about, zero packet loss. I mean, I think that comes without saying. High packet flow rate, that goes back to our bandwidth. And of course, in the flow fabric, and come and see us in the booth, and we can talk about acceleration and optimization and all the good stuff we're doing there. Capacity planning. The ability to do telemetry, the ability to get this information in real time off the equipment that's happening allows us to not only do capacity planning for big purchases, but when we talk about scalability, and this is something that we've done many times in the past, you can see the curve of your busy periods in the day, and we can expand, I don't know, let's say we expand CSCF traffic nodes within a IMS core. We expand that out during your busy periods. And then at night, your billing systems, they require more CPU power. So you scale in your IMS core, and you give that CPU power and that, the rest of that horsepower off to your billing system, because they run batches at night because they're on some old, I don't know, CNOC system or something like that. Flow updates. This is very key. So the fact within the flow updates, we can do on-the-fly movement adjustment of traffic based on profiles and all that good stuff, and real-time complex service function chaining. That sort of ties into the previous thing. We're talking about creating flows on the fly, routing flows in an intelligent manner, doing tiering, preferring certain traffic flow over the other. So I think I'm done now.
Okay.
And I will pass back off to you. Thank you very much, everyone.
Great. So we got off to a little bit of a late start, so we're in a bit of a time crunch here. But we talked about all this wonderful stuff. So how do we actually build this, right? The need for this disaggregated architecture requires a need for the ability to monitor it, to orchestrate it, to automate it. Some of the key factors that, again, from our customers, right, that these technologies, based on the pace of innovation, need to be open source. They need to have open interfaces, because you can't have anything proprietary at this scale. They need to be microservice deployable, as Dan demonstrated in the Kaloom architecture, right? So you need to be able to port things very easily, and you need to be able to scale them out very elastically. It has to be very capable of a near real-time architecture, not only in terms of the pay or the rate at which it's sending data, but also if it's a consumer of that data, then it needs to be able to consume that data at a similar rate. And it needs to be to consume a minimal amount of resources, so just sufficient to allow it to run. And then it has to be dynamic, right? Not something that's centrally controlled or attached. It has to be very gateway friendly. And again, as I mentioned, it also has to be fungible. So with that, this is one of the architectures that we've looked at. This is just a logical representation, but essentially, you have a real-time message bus, and then you have a rules engine, right? So you need to be able to trigger something. You get an event, and you need to be able to trigger on that event. And I'm going to talk about this a little bit on the. So this will empower you, right? So if you're a telco operator, one of the key things that's on your mind right now is I have all these SLAs. How do I align with those SLAs, right? There's the issues of capacity planning. There's the issues of scale. There's the issues of resource provisioning. How do I do that in a way, as Dan described, I gave you the example of moving the resources dynamically. Well, you need to be able to unlock the information to be able to do that.
And just to add on to it, I mean, one of the most important things that I've seen, at least within the telco operator space, is it's not sufficient anymore to get the bill at the end of the month. It's not sufficient to find out 6 weeks later that you missed your targets, you pay the penalty, and you adjust. What we're talking about here is enabling rapid remediation, rapid response. And by rapid, I mean automated. I mean that we see behavior heuristics occur within your network, and we adjust on the fly. And eventually, we're going to get into some logic, some algorithms, right, some learning. So.
Right. Thanks, Dan. So, and again, just what we observed is based on as we talked about. So this all comes together now, right? We talked about all the massive number of participants in this network. They're all talking to each other, including us, right? And the rate of data that's flowing through the system is immense. Now you really need a new way of thinking about how you're going to ingest the data and how you're going to process it. So gone are the days where the data was static and you needed to be able to, or you had the luxury of being able to move it into your Hadoop cluster to be able to process it, right, for batch analytics. What we're observing now is a shift to be able to compute or to process this data in real time in a very streaming fashion. So as you'll see, there's you'll see batch, you'll see streaming, and batch is it's not gonna go away because it's still required for some machine learning methods. But what I do want to demonstrate here is that we're seeing the shift from the older Lambda architecture, as you'll see on the left, which includes both a batch and a streaming layer, to simply a streaming layer. And now I do want to reiterate that the architecture on the left is not going to go away, but what we're seeing more and more of for these for these type of architectures is essentially this.
And one of the key reasons of the thing is that when we talk about, gone are the days 1, 2, 3 VMs, and that's my service or a couple servers. When we talk about hundreds of thousands of containers, polling doesn't become an option. SNMP, you're gonna kill your network just polling to find out what your network is doing. And so that's really one of the keys is streaming, being able to handle it, being able to send streams of information outside of your fabric or your traffic handling networks and deal with them in an intelligent manner. And that's really where we're going.
Right. And then just to continue from where Dan left off, previously, he talked about the Kaloom architecture and he talked about the telemetry. Well, this is where the telemetry actually goes, right? So we stopped there very deliberately because we wanted to share this with you, is that this is what we're actually doing today. If you stop by the booth, this is what we're doing today. We're sending we're sending the messages. We have different types of topics, and for those of you who may not be aware, a topic, on a message bus, for example, is just something, think of it as a channel, and if you're tuned into the channel, there's the messages are broadcast or published on that channel, and you can listen to those messages and only those messages of interest, right? And if you're a consumer, this is essentially what you really want, so you can sort of blot out all the other noise. And when you have this event bus, these are very, very, very fast. The messages are being ingested at a very fast rate. And then you need a compute engine. So the premise of this architecture is that you want to be able to move, so two things, right? You've got the dynamic data that's flowing in very, very fast, right? And as you'll see at the bottom, that's how it's processed. You have an input data stream, you've got batches of data, right? Because what it does is it breaks these streams into batches, and it's processing them in memory, right, at these intervals. But the idea, the way that it's able to do this is you're able to move the dynamic data very close to where it's being processed, right? That is key. And the rest of the data, the non-dynamic, or I would say, I wouldn't call it static because no data is really static. If it was, it wouldn't be there, it would be archived. But, or I should say less dynamic, would be moved away or closer to the end user because that's where its value is more appreciated. So these are some sample stats, and again, these are some live, these are, I wouldn't say live, but these are some stats that we're actually collecting off our live systems right now. On the left, you'll see the stats that are emerging from the interfaces on the Kaloom flow fabric, based on the transmit and receive bytes. There's also the stats that we're receiving from our container that are running in the flow fabric, and then there's also a whole combination of different messages from, again, these are some arbitrary messages that you can, that are being spewed from actually a script, because we want to be able to see how we can benchmark or stress test this, right? And essentially what the servers or the different types of hardware and the services that they perform, and what the errors and the event types are. And then what I really want to quickly walk you through is that, you're looking for specific events, right? So if you look for a single event, right? So as I mentioned, there's all these streams of data that are being spewed. Well, a single event is just something that you're watching for in a single stream. And you're applying some sort of logic to it. It could be simple as yes or no, right? Or green or blue or whatever it might be. But then you have the streamed events where you have many, many events, and you're not just looking at one event in isolation. You're actually looking at, or for patterns in the stream to lead you to an answer, right? So whatever business logic you've applied, you now want to be able to extract a pattern from it. So you're looking at these events as a whole. But then you have something that I call complex events, which you're not just looking at not just one event and then not just multiple events in a single stream, but you're looking at many events across many streams, right? So you're scaling out and you're scaling up, and the challenge with that, right? It brings a whole new set of challenges, right? In terms of how that can be parallelized and what type of computation requirements are required. And with that, I just want to conclude that we're almost out of time, but please stop by our booth, and I can share with you some of the machine learning method that we've sort of employed, and the different models that we've applied to this data to come up with well, some answers, right? So whether there's simple classification problems, or I'm trying to design a recommendation engine, or whether it's something as simple as a linear regression where I'm looking at a whole bunch of parameters and I want to find out the correlation effect, and I want to find out which parameters are relevant, and to that particular problem statement or hypotheses. And then also looking for root cause analysis, because as Dan described, once you have this chain of all these assets and components, the problem that is being exhibited could have been caused by any one of those components. And you want to really understand where it started and where that burst, or how that burst sort of or the nature of that burst, right? And where it started and its source, and being able to watch all these streams in parallel is key to be able to do that.
Well, and I mean, just to add just a little bit more depth to that, it's so important because I've been in operations, and I think we've all sat on root cause analysis. Okay, we've had an outage. Okay, we had an outage. It turned out it was some piece of equipment somewhere. We had to do something to come back on. But it's never that isolated. Sure, that's the initial cause. But when you do some of these root cause analysis, you go through the Apache model and you talk to people and you go all the way back, you find out, well, maybe that piece of equipment failed because some guy couldn't get a patch because there was some piece of source of software that he wasn't able to compile, so it didn't get done. Well, that's one way. But when we get all this composite data together, I can see in the past, and I can see the run-up of all the different impacts that led to something. Once I'm able to determine that, I can put automatic mediation. I can put automated remediation of these events. I can see the heuristics that's about to cause a blip in my network, and I can deal with them before the fact. Yeah, root cause analyses are wonderful, but it would be better not to have one. So I'll leave you guys with that. You got anything else? Any questions? I know that we're kind of running late. So if I understand your question, you're asking us if we sort of used any sort of data model to come up with it, or?
We have to build that in conjunction with the customer, because so taking a machine learning model and just applying it, first of all, you have to understand whether machine learning is even applicable to the problem, right? Is it something that you want to learn from and you have to build a model for it, or is it something that can simply be streamed, right? Because those are two different architectures. That falls into the realm of the Lambda architecture, right? What you could do is you could undertake the Lambda architecture and you could have one flow where the data is being ingested into the batch layer and you're building a model and your data is being built. The history of your data is being built and you're building and training your data set in that layer. And then your live events are streaming through this, well, of course, through the streaming layer. But then as those two merge, because you're going to have to converge them back into the message bus to apply a business rule. So something that we didn't show there, because again, it depends on the business and the nature of the problem you're trying to solve. But you would need a business rule at the end of that says, okay, this is my event and this is my rule. Does it violate the rule or does it pass? And then,
or does it hit and then take action accordingly?
Correct.
But if I understand your question maybe better, I mean, for the purposes of this demo, when you come over and see, I mean, the first thing that Narendra and I wanted to do, of course, was get some event streams coming from some different key areas within the setup. So I got the switch, I got Docker stats, I got Ceph stats, I got IO stat from the hardware. We combine all those together. The sort of advanced stuff of this, I mean, we're here for a teaser. We just started, so we're come see us when it comes time to release time next year, and you can see the sort of full-blown solution. But we kept it generic, sort of on purpose to show, look, there's a lot of raw data. This is the way that we can go forward. The idea of dumping my night's data, letting Hadoop chew through it for 12 hours. I come in the morning and I find out, damn, I missed my SLA by 20% last month, and now I'm broke. Those are real world images. Do I have the ultimate solution of, hey, spin all your data into this and it will make you money? Absolutely not. And that's because every single case is unique. At the same time, as you were saying, Narendra, there is the idea of, yes, you have to do it for a specific business case, not one fits the other. But the tenets of getting the data are all the same. Regardless of what you want to do with it once it's ingested into your injection engine, what we're taking away from here, using the Kaloom flow fabric, using the Lenovo setup with the RHEL, is the fact that we just wrote this on a weekend to spit out the streams. We were, at one point I was using 0MQ, he calls me, says, I want Kafka. Boom, we dropped in Kafka 10 minutes. We got streams coming out everywhere. And then the issue becomes the big one. And this is, I think, the one that we're getting is, you get so much data. And what we want to do is find a way to synthesize it. Yeah, go ahead, sorry.
Out of curiosity, what's the rate of the ingestion? How many messages per second?
Oh, we have not
Honestly,
we didn't even bother to try because I haven't hit a max yet. I mean, the ones that we're doing, so you figure 24 interfaces reporting 3 times a second. So what's that? That's 75. Then the Docker stats, six servers, Docker, 12 containers, so 6, 12, 78. I think we're around 440, 450 a second. I didn't bother to look at a metric, to be honest, because it's just a proof of concept.
This is on a set of hardware that's about 3 servers thick, and just.
Well, you can come see it. I mean, we have a 16U rack. It's 6U servers, a 2U switch, and 2 laptops.
Right. So this isn't the idea. What we really want people to walk away from here with is that when we talk to the telecom providers, at the end of the day, the people that are responsible for this are the operators, right? Who are managing this infrastructure. We want to empower them because when they receive an SLA directive from the business, we want to be able to provide them tools, and we want to demonstrate how easy it is, right? If I'm an operator, I don't have maybe the skill set or the time or the luxury to be able to go out and learn, about machine learning models, right? And how this data is going to be trained. What I do want to understand though is how can I put in a framework so that events can be brought into my plumbing, and then the business rules can be applied independent of that. Right?
Without locking ourselves,
Correct.
Without locking ourselves into a charge, like I'm operators, but the charging system model, the charging system was like the untouchable part of the network because everything went in there and then just kind of disappeared and they'd spit out something. I mean, we want to keep it so that not only do you have this option, but as as things change, as you learn more stuff, you can tack it on without having to reinvent the entire wheel. Yeah. Any other questions, guys? I hope you found it entertaining info. Come and see us, 208. We'll be here all week. Thank you very much.